Hello and welcome to another video on using Tcl tasks. This presentation will be about using the VW plus debugger inside of tasks. The debugger is also standalone in that it can work without tasks on other Tcl programs. However, tasks include special support that makes it easier to use. It is included with the tasks distribution at GitHub. It's comprised of 6 commands, 4 of which are listed here. The VW plus is the data viewer command. There are 2 types of breakpoints, and there's an instrument command that will automatically put these breakpoints into a procedure dynamically at runtime and remove them later if desired. And there's a PDF manual available. This is the first page of the manual with a page on viewing variable data, setting up breakpoints, working with procedures or methods, and instrumentation that is used to insert breakpoints for you. And there is a section on using it with the tasks module. So let's get right into some code. Here we have an example program using the Fibonacci math library routine, and we create one tproc that calls the Fibonacci routine inside a task and then computes the number of digits in the resulting number. If you've been watching previous videos, this will be quite familiar to you. So one thing that's different is we're going to load the debugger with this statement here. So we're simply going to source it from giving it the full path to where the Tcl file is. Then we load tasks with a package require, open a console, output a message, get rid of the TK window we don't need. After the tproc is defined, we then launch 400 jobs using this range of command, which will be new to 8.7. It'll be called lseek. Anyway, this is computes a range of 400 numbers starting at 10,000 every 200. This is how we queue up each job, and then after that we wait for it to be done. And then finally we just put out a little message. Okay, in this example we are going to start off by using manual breakpoints that we insert into the program. And here are our breakpoints. We're also going to include a VW plus command, which will bring up a window to show us the global variables that have been defined since we started up. And these are all in the main thread. So let's, we have one global variable we're going to set called alert, and we're going to set it to 0. And so we're going to run the program here. Now to proceed from this breakpoint number 1, we'll hit the go button. And it'll say it's continuing, and then it's stopped here at breakpoint 2. However, at breakpoint 2, it has done the tproc. And one thing about these, the global data viewer, is that for performance reasons, while it will update the values of each variable it currently knows about, if there's been any new ones, you need to press the refresh. And a tproc is going to create some variables using the name fib size. So we click refresh, and we can see here that we have 2. We have fib size 0, which is a thread ID. You can tell that from looking at the value. And fib size is an array. Now, if you recall from previous videos, the tproc name creates the array, and the array has these components. It has a job count, number of tasks or threads, the thread ID, which in this case is only for the first one, fib size 0. We could have more, and they'd be fib size 0, fib size 1, and so forth. But since we only have one thread, we're only going to have one here, and we're not doing any tracing, so that's off. At this point, if we go the next step, we're going to run this for each loop, which is going to queue up 400 jobs, and fib size 0 being the only task, he's going to start pulling them off one at a time. Incidentally, it's recommended that while you're debugging, you should set your task count over here. You should set it to 1, which makes it a lot easier. Otherwise, you're going to get the debugger is going to be running in n different tasks, and you might have n different windows popping up, and that would be a little unwieldy. So as soon as we hit this go, we're going to see that it's starting to process these jobs, and you might notice it's slowing down a little bit as the numbers are getting larger and larger. And we can hit refresh once again, and we can see now that fib size has some additional items here. It's starting to pick up the args, and this array, we could go all the way out here, but it's actually pretty big. Okay, I paused the recording and waited till it got finished. The last one was 89,800. And again, we're sitting here at breakpoint 3. The jobs have been started, and the next statement is we're going to wait for them all to get done. So if we hit the go button, we'll see that it's now at breakpoint 4, and everything is done. We can look at fib size here, and we see that in the return values, we have all the return values now. All the args are here as well. And it'll say that somewhere in there, it's going to say that it had, okay, here the number of jobs is 400 jobs. And since we've waited for them, they're all done. You'll notice that number has the last value from this for each loop. And so this is just a pretty typical way that you might do some debugging by putting in breakpoints. Now, one of the advantages of having them in the code is that you don't have to remember to set them up the next time you want to run. Any that you don't want to use, you can simply comment out. And if you want conditional breakpoints, you have the full power of the Tcl language to create an if statement around a breakpoint that you might like. Okay, so we're finished with this run. And now one other feature of the BP plus breakpoint is it takes a parameter after the message, and if we set that to 1, then any breakpoint that has the alert variable at the end will no longer stop at that breakpoint, and it'll do what I call an alert point. So if we run this again, and finally it reaches alert point 4, continues on automatically, and output's done. Once again, we can look at our results here, and we see the same thing. Okay, now how do we run this inside tasks? So in addition to our 4 alert points, we're going to stick 3 breakpoints inside the tproc itself. Now, when you're inside a tproc or anything that ends up being a procedure or a method, you use the second form of the breakpoint, the LBP, L for local. And now if we run this, we get 2 new windows that came up. We'll move that over here, and we still have our global variable window out here, and we'll refresh that. And after a little resizing, we can see that in the code window it has a pointer to line 3 showing us that we're on this low-level breakpoint number 1. Now I should say the reason I called it low-level is because we're not doing the instrumenting yet, which would automatically insert breakpoints. Also, the label that you use here has to be unique because that's what it actually uses to figure out where to put the 2 dashes. Now, let's make this a hair bigger, and if we step this, we'll see that we've gone to the second breakpoint, and in our data window, notice it has the name of the procedure that we're in is fib size. N has returned a value from calling Fibonacci, passing in num, which was 10,000, and it also has computed the result string, and in there it says 10,000 size points at, and the size is the string length. So this N over here is actually 2,190 digits long. Now if we hit go one more time, actually I hit that twice. What we see, it's back up to line 3 because fib size as a procedure is being called over and over again for each item in the queue. So if we look now, we see that num is the next item, 10,200. And he output this debugging statement. And notice that we now can use putS commands directly inside tprocs. Even though it's a separate thread, it will get sent over to the main thread and put out on the console, and it prefixes it with the name of the task that wrote the message. Now notice there were a number of global variables here that we set up, and we're not seeing them in our global variable window up here. And the reason is these are the globals in the main thread, not the globals in our separate thread. So you might say, well, how can we see that? Well, that's what these 2 entry boxes are, here and here. Command entry will execute a command in the console in the context of, well, global context, the same as you get with widget callbacks, an after statement, runs in global context. Up level will allow us to execute commands inside the actual procedure that we see here in the window. So for example, we could type in the VW plus command here in the lower box. It'll run in global context, and we have an abbreviation, an alias that we set up. So we can just type V, and with no parameters at all, it's going to assume that you want only the globals that have been created since it started up. Now, what does since it started up mean? It means since it loaded the debugger. So if we look at our new window, we'll see that some of these values here, like numbers, is now 1. First time it was incremented, it got set to a 1. Recent jobs array, so recent jobs of 1 is over here, and it's going to be set to num. And if we click on that, we'll see that the result shows here's an array. Now if we step down here, we'll notice now that in his local variable display, num is now 10,200. Also notice that in the global variables we have argc is 1 and argv is the argument that was that this task was called with. Now as we continue to step through here, we'll see numbers is increasing. As we're working on more jobs. However, the recent jobs and recent outs, these are the indices. They don't update automatically either, so you have to hit refresh. So we're up to that array now. If we click on recent jobs, we'll see that it has 5 entries. So these are the jobs, and the out, these are the values that it's set with the statement set recent outs to the result string. And now if we want to, we can, instead of stepping it singly, we can do the run command. And run is just like an auto single step. And I'm going to move this off screen a little bit so you can see, and I'm going to hit the run button. And then also there's a stop button, so I can hit stop. And what we're going to see is some of these values are going to start changing here rapidly. Okay, so you can see the argv is changing, numbers is changing. All these values are changing as it's running through these jobs. And in addition, we can see, well, it's hard to see, and that's where these, because we're spending most, okay, you notice once in a while, you can see a little flicker of this 2 dashes as it's moving, but most of the time, the last breakpoint that it was at was here because it's spending most of its time in this Fibonacci. And one way we can see that is if we start adding some delays, and that's what these spin boxes up here are for. And if we add enough delays, you can kind of get to see how it's running, and that it has to wait over here on the Fibonacci call. That's where the time is being spent the most. Incidentally, these there's 3 spin boxes, and this is the hundreds value, the tens value, and ones value. There's only one result, but you can do the increment differently depending on which one you use. So if you want to go up by tens, you use this one, and I'm using the wheel mouse to do this, or the mouse wheel, I should say. And again, we can stop this at any time. And so we have gone through up to 62,000. So if we go into the main thread again and click on this, we'll see that the return values that it's gotten so far are up to the 259th one, starting at 0. Now, it queued up 0 through 399, but it has, and that's how many jobs are there. And there's one thing we can do now to take a look. If we run the task monitor, we can get a better picture of what's going on here. And I will okay, I've stopped this. Incidentally, there's a new command in the T group set for fib size well, let's just add 1, which lets us add a task dynamically to this so that there will now be 2 that are working on this. And as soon as we do that, we get another debugger window coming up, and this is why I suggest that we don't actually run more than one in the debugger. But if we start him running, notice we still have this guy. He stopped. So now what's happening is that fibsize1 is taking over the load. And if we look at the task monitors, you can see that it's now accessing things. And if we go back to the fibsize0 job, our task, and we set him running, now we can see in the monitor up here that they're starting to each take a job. And the output, the debug statements are alternating a bit. I think the moral of this lesson is don't try and do development with lots of tasks and lots of windows unless you have at least 3 or 4 monitors. I have 3 on right now, and on a 4th that's in a table on the other side of me that I can turn on if I need to. Okay, so it's finished. It got to alert point 4 and it's done. And you can see here that of the 2 tasks, one of them did 328 and the other one did 72. And also you might notice in the share column there's fibsize0 because this is the main task in the group. Being main only means that he's the one that has the queue and the originally has the queue, and the other one he is sharing that queue, and that's how you get this single queue multi-server arrangement. Okay, I'm going to exit these, get rid of all these windows here. Okay, and now what we're going to look at is the instrumentation capability. So the first thing I'm going to do is I'm just going to comment these out over here because we don't need them when we're instrumenting. And in the list of initializers, you'll notice that the way we got the debugger in is with these new commands that start with a plus sign. So plus debug equals, and then the full path, that's the equivalent of the source, only this is used so that it does the source and puts it in the right place in the task as each one as it gets created. And I have commented out here a command plus fib size. That's necessary to actually have the instrumentation done for fib size. You'll notice we got Fibonacci here without anything in front of him means import him. This is a commented out Fibonacci instrument, which we're not going to do just yet. Okay, so let's run this. Now incidentally, you might notice that it only did 3 alert points, and that's because the code is actually in the main thread is sitting on this fibsize wait all. He's queued up the jobs. It spit out this job started, but it's waiting here. That's why we haven't gotten to the alert point 4 yet. Okay, now the difference now is when I step this, you'll notice it's stepping through every statement. Also, we get a nice Unicode arrow to distinguish between when we've been instrumented and when we haven't. And it does some special code here. If you really care to look, in this menu there's a show instrument. It's kind of ugly where it puts all the instrumentation, so I don't advise turning that on unless you think the instrumentation isn't working correctly. But you can see all the LBP plus statements it puts in. It uses 2 arguments. Step-instrument is how it knows it's in instrumentation mode, and this is a unique ID that it generates. A couple other things you can do in this menu is you can list all the call frames. And so we can see that we're in fibsize here, and we're actually called by code that is generated by the tproc command. We're called with that, which simply calls the fibsize proc, passing in the argv, whatever it is. And once again, if we stick a v in here and run that, we'll get another window. So here's what the argv was. It was only 10,000. Anyway, that's pretty much what you can do. The only other thing I can show, let's turn on the single stepping through the Fibonacci code. Now that's not something you'd want to do and then run it, because it's something that might take a couple seconds could grow to several minutes or more, because the instrumentation can take up a lot of CPU time for him to do that auto stepping. But let's run this. And now as we step this, we're now on statement 4, which is going to call Fibonacci and when we step one more time, we get his window, his variable window, and we're now in the Fibonacci code, and we could step that through. Now, one thing you could do is, instead of instrumenting this, you could go back and just use a breakpoint, and you could make it a conditional breakpoint. One common thing that I often like to do is, I'm always unsure when I have like a loop that's going 1 to 10,000. Did I do that one too many times or one too few times? And so you could put a conditional breakpoint in here that said that if I is greater than n minus 10, say, you would then be able to then set a breakpoint there and look at the values and then single step through that. Well, not completely single step through it, but you could repeat that breakpoint over and over again, looking at the data variables to see if you have properly handled that last iteration of that loop. Just to show you what happens here, if we hit run, you'll see that it's spending an awful long time in this loop. And look at the size of these values here. They're getting pretty big. Now, one of the things you can do while it's doing something like that to speed things up is this auto list will stop this from updating. And if you click that, you'll notice now it's going a little bit faster. And if you really, really wanted to speed it up, you'd say, don't do any more of those. And so now what's happening is we're not doing any of the breakpoints inside the Fibonacci anymore. And so we're back to watching the code run inside fib size. And you can definitely see that it's waiting over here for Fibonacci to get done each time. This little effect here, if you don't like that, you click manual geometry, and then you can set that up so at least it won't be changing the window size. These black squares, they mean these are previously used labels and entries, but they're not available yet. Now, if we stop at the beginning, you'll notice because Tcl is a dynamic language, variables aren't created in a procedure until the first time you do something with them. So notice the only variable here that is set is the input parameter. And now as I go down to and go across that statement there, now we have n is set, and the next thing we're going to do is set size, and he shows up, and then finally result string. So while we're running this, this is kind of handy sometimes because you can get a feel for almost like a little quick profiler to see where you're spending your time. At any rate, that's probably about it for this this tutorial, and I want to thank you for watching, and goodbye.